this is the plan for today. So I'm sure you guys received my email from last night, but then I wanted to quickly go over this and then demonstrate a few things you can possibly do with these two the processing script. And then we go back to, we go to the data set review. If you guys have taken photos and then process it on your own, if that happened, we can go over this. And then we're going to go and then create our own Colab notebook. I strongly recommend you follow this through while I'm writing the code and then to change the setting and all this, because it could get quite confusing when you're trying to do it on your own. Okay, and then we're gonna start writing the code for the TSNE, and then shortly after that we're gonna have a break time. Then we're going to come back to the Google Colab and then integrate that Python script that you wrote into the Google Colab, so that you can run your own Google Colab and test it out, the TSNE, to produce your own image. And then we're going to download the process image from the Google Drive, and then we're going to use some more processing sketch to analyze your images in maybe a few different ways. Let's see how much time we have at the end of the day. So I'm gonna go start with the.
Before you start, did you send us an email?
Yes.
I didn't get any.
Oh, you didn't?
What was that about?
It was about the summary. It's set. Yeah, this email. It says you're already included in the email chain. Maybe my email is in your spam folder.
Yeah, maybe it's in the spam. Sorry, I'll check.
Okay.
Thank you.
Yeah. Okay. Now let's go to the resizing. So there are two processing sketches here. One is a resize, and then the one is the image splice overlap. Let me make the font a little bit bigger for you guys so that you can see a little bit better. Okay. So here, this is something that we already wrote yesterday. I was having some of the drive issues, so that I couldn't demonstrate in its full capability. But the idea is that once you have, let's say here, I made this input folder and then output folder. They're the exactly same images, but then when you go to the property here, when you go to the detail, this is a 1024 by 1024, right? And but then if you go to here, this is 128 by 128. So you don't have to worry about, let's say, changing the resolution one by one in the Photoshop. You can change the resolution and then the everything, like naming conventions and everything in the with this script as a series. So if you put your images in your input folder, all these images can be output as the your set resolution, set size, so that every data set has the same convention. There is no discrepancy within the data set. This kind of a practice is a very, very useful if you're doing some sort of a manual training for the CycleGAN or StyleGAN. So this is a very, very good tool to have. And another thing that you can use this for is that let's make another folder here. I'm gonna say it as input crop, and then whenever you make those changes, you have to change this file name, folder name, and then I'm going to put some of the images that I have as a let's say horizontally long view. When you take photo, unless you specify it as a square, a lot of the photos you take is either 16 by 9 or 3 by 4 ratio. So what I'm going to do here is that go to some of the, let's say, photos that I taken in the past. Let's say I have a bunch of these images, right? I put it here, and then I process this. Maybe I should just make a new folder to find it. Okay, so I'm going to rename this to top. And here, let's check this resolution here, right? So this resolution is a 4000 by 3024, right? But that's like way too big, so we want to cut it. But let's say you want to make it square, right? Then ideally you want to cut it to let's say 3000 by 3000, let's say. That's what you want. And then if that is the case, you change these numbers to 3000, 3000, 3000. And if you scroll below, there is this line. If you do the, it depends on where you do the bracket, it will either try to crop it or make it fit in the square. So what I mean by that is that if your image is this horizontally longer, if you do crop, it will literally just crop this like this, like it. But then if you do the matte, what will happen is that it will draw like the boundary with your background color. So right now my thing is on the crop setting, so that I can crop the photo to this exact size. Let's test this out, okay? I changed the geometry and everything. Well, this window is just showing that it is processing something. Because this is a high resolution image, it might take a little bit longer than the one that we had, about 128. But it should have, oh no. This is input, okay, output crop. So as you can see here, everything is cut to the rectangle shape. And then if you wanted to compatible with, let's say, some of other like machine learning tools, you probably want to change this to 124, 124, 124, and then you can do it again to make your own image. So I think that covers the resize, Matt. Is there any questions that for this tool? If there is no question, I'm going to
ask
move on.
just a very simple question. How do you enlarge the text in processing? I forgot that.
And here on the preference, and then you can change the font size.
Oh, I see. Okay.
Yeah. Okay. And this is done. So I'm going to close this down. And we're going to go to the image splice overlap. Image splice overlap is the segmentation tool, basically. So if you have this image here, you want to cut it as a grid system, right? So that you can extract information like this. How you do it is that you put your target image in the data folder inside of the image splice overlap. Here, there's a data folder, right? And you indicate the name of the file, right? So the name of the file here is the test.png, and the namespace here is that you're aimed the name for your output. So as you can see here, this is cut into smaller pieces with this name convention that I assigned by tile number. So this means that the number here means that this is a cut by 256 resolution, right? Because the number increased from here to there is a 256, so that it has that, let's say, the same dimension, indicates the dimension of the images, and then the placement of a tile in your whole image. So I'm just going to delete this to show you the demonstration, to just give you the demonstration. What was the image size here? Image size here is 2448, right? So if you want to cut it, let's say to 256, what else here? 256, 256. And if you click this, it's a cutting to the smaller sizes. And what you have here is everything at the 256 size. As you can see, like these are more desirable than the let's say more of a perspectival image that is downscaled, because in reality, based on how many grid system that you're going to have for the TSNE, and then your targeted the site condition, you want to scale this, at least ballpark the scale of your architectural element in the way that it will look correct in some ways. If you want to hack it and then make certain the parts look bigger, that's okay. But then just as a golden rule of thumb, you want to have these in fairly good scale. So this covers it. I put all these like tags here to help you understand what each line does, and make sure to follow these steps. And another thing I guess I missed here is you have to change the size to here, aim image size. Okay, so, and then this is where you change the name of, or this should be literally the name of the data that you have here. So if you do just F2, click your file and then hit F2, you're in this mode, and then you just copy and paste your the text information for that, or the tag for the image into the processing, just to be safe. Okay.
I have a little question in there.
Yeah.
So you can only load in one image per time.
For this one, yes. But for the resize, you can have a sequential images and then resize it at once. But for this particular thing, as of it now, you can only cut one image per per time. But if you use a for loop, you can actually let's say cut multiple images that is in sequence. Let's say here, I'm not going to finish it, but then here.
No, I understand, definitely.
Okay.
But the thing is that also the next line, the image list, you created a new array. What is stored in there? I don't really get that.
This array list. So image, this is let's say, am I really using it or not? Let's see. Sometimes I change the code from one thing to another thing too many times. So I also confuse myself. You know what, let's test it.
Yeah, because the pictures where we when we cut them, we didn't like.
So I think that in the previous version, I actually had that the multiple images cutting to the smaller sizes, the function that you were talking about. To do that, you need this array list, right?
Yeah. Okay, makes sense. Yeah.
Yeah. Sorry about that. Yeah, this is unnecessary. for now for this particular application. Okay.
Thanks.
Yeah.
Actually, I have a quick question.
Yes.
So to use, I mean, this one or also previous one as well, we need to go through that, I mean, manipulating the original images one by one, right? By using Photoshop.
You just need to do the perspective stretch. You know, perspective stretch is a computation more harder to simulate in the processing.
Gotcha. Okay.
Yeah. And based on the, let's say you're taking the photo from the pedestrian view, and when we're taking the photo, we're not a machine, so we cannot, let's say, always take the photo in the same angle, right? So that's another reason that I didn't implement it in the automation part. So I can actually make it look, correct in the Photoshop first, and then cut it in the processing.
Got it. Actually, I have another question. So I think this tool will be very, very useful to get some images in terms of the buildings or some elevation that has kind of repetition. But what about like first-story building or two-story building or kind of residential, that kind of building? So in this case, how did you do that? How did you deal with that? Get some images.
So if you want to, you can actually sort, let's say, for the residential buildings, naturally, if you take a photo, there will be skies, right?
Yeah.
Skies and background information. Ideally, you can actually sort that information out and then automatically delete it. You can code it, but then that's like so much effort to do, for that housing project. So if my focus was to do housing project, I should have definitely include that information in this code. We will cover something that could potentially help you figure that out on your own at the later today. We're going to do we're going to do some like pixel sorting, and we're going to target some, let's say, like a color information of a certain like a tile of your image, so that you can actually omit that information or substitute with other information. That will come at the end of today's tutorial.
Okay, thank you.
Yeah. And any other questions? If no question, did anyone else? Did anyone try to make this data set on your own? No takers. Okay. So the idea is that you have a bunch of these images and you're slicing this down, and then you upload this with your convention. Like, for example, this is a 128 by 128, right? And how I approached it is that here, like, I already uploaded these two folder, which is one is an image 512, which and another folder is image 128. I made these two different sets of images because when we're using the Google Colab, Google Colab doesn't let you use too much of a memory because it is a clouding computing system. So you don't want to, let's say, overwhelm the entire system by your own one project. Google wants to distribute the memories, this equally to the everyone as possible as they can. So when I was running my code, when I was testing the code on the Google Colab, there was some issues with the bigger images. So let's say you want to have a grid, and then your goal is to make just, let's say, 10 by 10 grid. You get it, 10 by 10 grid. But then some of you might want to do bigger scale, let's say 30 by 30. This will have a completely different effect, right? Because the smaller grid that you have a more of a similar facade element laying around like this, and some other dissimilar geometry popping up like this. But then at the end, you're going to end up with a very, homogeneous kind of condition. Homogeneous or, very like a heterogeneous condition, but then with a less variety. But if you do 30 by 30, you would have a bunch of different facade elements just, all over the places. But, that's more visually, let's say, more useful, but then this is maybe more useful for the actual like building composition. So it's really up to you how you use these the TSNE tool. But let's say your focus is to make the actual facade in the very high detail, then you probably want to use a 10 by 10 or even 5 by 5 in some cases. Then you want to use something like image 512 or even 1024 to ensure the high resolution for your building element. But if your goal is to create a nice image at the end of the day, then you probably want to go for the 30 by 30. In that case, you have to use image 128. So these are some of the considerations that you have to make before you run your stuff. It's the same for your own desktop computers too. If you have your Anaconda environment installed and everything, there's always a compensation for the using high resolution images. It takes longer. Sometimes you run into the unexpected error because of you are running out of the memory. So all these issues, you have to work in the limit. So if there's a bucket, you can only fill so many things. Like it's either could be big 3 things or it could be many small things. So be realistic on how you use your software or your machine. So that's why we have these two. I would recommend you queue the download of either of these, so that later on that you can actually use these images into your own Google Drive, so that you can run your the TSNE through the Google Colab. Can you guys download any one of these 2 folders based on your need, so that we can actually test this out on your own Google Colab notebook? You should download just like now.
Okay. Yeah.
It will take a while, and then it will take a while to upload as well too. So, okay. So if you go into this, it's just the same images, but with just with the different sizes. Okay, and at the end of the day, what we want to end up have is something like this, or something like this. This is a more of a 5 by 5 grid, so that this is focusing on the, let's say, more of a geometrical condition that is attached 1 by 1, and then we can later on sort some of the dissimilar parts out automatically through the processing. It's not perfect, but then it is a good sketching tool, at least. So we will cover that. And now we're going to jump onto the actual coding part, which is, do you guys have the PyCharm installed?
I have it.
You
Yes,
have
I
it?
have.
Okay, thank you for answering. And if you have it, let's make a new file and save it as. I'm just gonna save this one on my desktop, but you can save it wherever you want. We're going to name it. So this is actually, I put the tutorial here, but then for you guys, you want to actually put it as a TSNE grid. Okay, so TSNE, the underscore grid, and then you have to define your extension PY. This is actually very important. So make that as a save. And once you save that, you have, yep.
Sorry. Yeah, I don't think I saw this program in the instructions. Sorry if I didn't see it. What is the name of this?
PyCharm, but there is an alternative that you can do. So you have your Google Drive, right? Account.
Yeah.
Yeah, and just quickly follow me, okay? So on the My Drive, you want to make a folder called the Colab TSNE, this Colab TSNE.
Okay.
And then make the folder TSNE Grid Master.
1 second.
Mm-hmm.
TSNE master. Okay.
Okay, and then you come here and then right click. And go to the more, and then click the text editor.
Text editor.
And you want to create new text file once you're here. And
wait, in more, what do I select? When I
new. So let me start over. More and text editor, right? You're here, yes?
I don't have that option, text editor.
You don't have it.
It says Google Apps script. No, connect more.
Okay. So this is the PyCharm, PyCharm Community Edition. Don't download the professional. Community is free. So I'm going to put this in the chat so you can use this link to go download. And you can download this here like this and then install it. It's very quick. So I'm gonna wait, maybe like 5 minutes for you and then start. Okay.
I'll install it.
Yeah, just let us know when you finish the installation.
Yeah. Meanwhile, probably you can just tell us again, how did you create a new project inside PyCharm?
Yeah, please.
Okay. So here, yeah, don't worry. Yeah, so here, file, new.
Okay. File,
yeah,
new.
You got that?
Maybe file. Okay.
When it's like file and then new, and then I got like a weird, I don't get any window. It's just like new scratch file. Is that?
Can you possibly share your screen so that we can try to troubleshoot from your screen?
All right. So, sure. Can you see it?
Yes.
I think I have same issue like you, so please.
Okay. What's happening? All right. So file and then not just new project.
Not new project, just new. Yeah.
Yeah, and then I get this little thing.
Yeah, just new. Get the new scratch file. Yeah.
And
select the Python if there is Python.
I must have Python. Oh, yeah. There maybe this. No, not Jupyter.
Jupyter Python is fine. Just do Jupyter Python.
It's weird, like because
Python over there. Python was there.
Where? Can I just like search
here,
it? Yeah, there.
Yeah, you can search it. Yeah. Yes.
There.
Yes. Yeah, and we save it. We save it with the name, correct name. So go to the file, and then the save as.
Yeah. Just okay.
Yeah.
Yeah. All right.
Yeah, and get the name convention that I told you guys to do. So which is the TSNE _GR.
No capital letters.
No capital. No capital. Yeah. TSNE. TSNE.
No. Okay, I don't have to write this in between. And then underscroll, right? What does it matter actually, the name?
Yeah, it's going to matter because I don't want to have a confusion between, a project to another project where we have like 8 different naming convention, because we're going to call this, we call this out when we're trying to run a script. So keep the same name convention is actually important. Yeah.
So what was the name? TSNE.
Yes. For some reason, I lost my.
TSNE agreed.
That's a big E.
No. Like, okay. Annotate, clear. Okay. Yeah, I lost my annotate screen, so I couldn't, exit. But now I can share my screen again if you stop sharing.
Yes, do it, please.
Yeah. Yeah, here. TSNE underscore grid.
Okay, nice. I wonder if this works the same if we use like IntelliJ. I mean, that's where I have also installed. I don't know if it's like
any sort of the editor for the coding is fine. Like you can use Jupyter Notebook, you can use PyCharm, doesn't matter. You can actually use literally use a notepad, but not notepad, but there's a thing called the Notepad++, and you can use this too. The purpose of using the PyCharm is that it has the most compatibility with these sort of a already like autocomplete kind of a situation, so that it's for me it's the most, let's say, comfortable environment. It's just an environment. Whatever you program, whatever program you use, it doesn't really matter. So don't worry about it. Yeah. Okay, so now we're here. Carlos, did you download and then are you up and running for this coding thing?
Yeah, I downloaded it, and then it looks like I needed to log in. So I just created an account.
Okay.
It didn't open just a program. It opened like a little browser. Can I just share my screen quickly?
Yeah, sure. Yeah.
Okay. So I am right here right now.
Okay. Did you get the professional version or community version?
I don't know. I just clicked the link that you sent me. This one.
Download, and let's see. You should download this one, community.
Community.
Yeah. Yes.
Oh, I see. Maybe I did it wrong. Okay. Okay, I'll do it again. Okay.
Okay.
So I have another question.
Yeah.
So for my PyCharm, I can't create new. I can only create a new project, and when I do that, it has the interface for me to choose whether this is based on Python 2.7 or Python 3. Are we using Python 2 or Python 3?
We're using Python 3.
Okay, I see. And so I have to make a new project first, and then make another new scratch.
Yeah. So what we're actually gonna do is that we're not gonna run it on your own computer. This PyCharm is just a convenient tool to write code on, and then we're going to upload this code to Google Colab so that you can run your the TSNE through Google Colab. So it doesn't really matter for that. The specific doesn't really matter that much as long as you have the autocomplete system and the auto indentation kind of a function. That's, I think, more important than the any other specifics. So yeah.
Okay, so you just need to write it down basically first and make sure it's running fine. Okay.
And make sure you check your saving location for your new file, right? Because sometimes PyCharm save your projects in a very weird location. It could be very deep inside of your computer. So make sure you're saving this in the location that you know of. Okay.
Okay, thank you.
Yeah.
Sanyan, can I ask a quick question? Can I share my screen real quick?
Yeah,
no
problem.
Question. Thank you. Let me know if you can see my screen.
Yeah, I can see.
Okay, so I think I've done, I guess. So actually, I just created a new file here, and basically this file is now TSNE grid and this border here. But sometimes when I use the PyCharm, I got just a little bit confused that, let's say I'm gonna print this one here, but it shows hi PyCharm something, and it runs main file, not this TSNE grid file, Python. In this case,
because you know, it's very simple. This is set to main.
Oh, should. Okay. So do I need to go here and
you just need to find that script that you wrote, and then you have to put that in the right you know, correct location.
Oh,
so,
got it.
Yeah.
Maybe like this here.
Yeah. It's easy. Yeah. Don't sweat.
Cool. Awesome. Thank you.
Yeah, no problem.
So Sanjung, just to recap, what I had to do is to create a new Scratch file, right? And then select Python?
Yes.
Okay, yeah, I'm there. Okay.
Okay. Now we can start. Okay, let's do that. Let's do it. Share the screen. Okay, we're ready to go. So first of all, when you're doing this sort of a machine learning tool, you're never going to write the entire thing on your own. The thing is, there are already a lot of like the tools that's already developed for the for you to use. So amount of import that you are going to have for this particular tool is going to be massive. So Python as is doesn't know how to do math. So first thing that we have to import is the mathematical tool, which is the NumPy. And then because it's annoying to type NumPy as a NumPy always, so I'm just going to shorten it to NP. And this, you can do this practice anytime that you want to do. If there is some the library name that is very long, you can always change it. But that's it. Before we go to that, I don't know if I can change I should change the size of the text.
Sorry. Yeah, can you make it bigger? Like
yeah.
thing?
Let me see if I never tried to change this. This one? Oh. Let's see. I didn't think about this. Why is it not giving me stuff? Setting control. This is an issue. Where did my preference go? You know what? I'm just going to change the my display setting to be bigger or something like that. Let me actually put this.
And also, Sanyan, can you let me know where can I download these NumPy or other some kind of plugins?
You don't need to download. All this library is included in the TensorFlow and the Keras stuff. So whenever you're doing the coding, you never actually download this library on your computer. you just call it to install, and then as long as you have an internet connection, it will automatically install it for you.
Huh.
Yeah, it's
Okay.
actually quite convenient.
Gotcha. But I don't know, for some reason, this one, when I just type the NumPy SMP, this shows an error message that no
Yeah,
module.
of course. Yeah, of course. This is not connected to any sort of a TensorFlow, thing. So for now, it's not going to.
Okay. Cool.
Yeah.
Thank you.
Yeah. Change font. Change font. Where's the change font? Yes. Okay. Oh, this is. 28 maybe. And I'm going to open that code again. No, I didn't want it. Huh? Does one of you guys know how to change this? I never tried to do this, so
I'm Googling it actually.
here, on here, and in the size to appearance.
Yes, I think if you go to the settings and then under editor, I'm not sure it's gonna work, but we can try it out. And then under editor.
Editor. Ah, okay.
Yeah, and then general.
Font. Yes, thank you.
Yes.
Yeah, 24.
There is also with mouse control. But yeah, that works also.
Okay, yeah. Yeah, fine. I'm going to restart file. There's always this sort of weird delay. Okay. So let's start. So import numpy as MP that we just covered, and then the thing that I'm doing right now here is that this is a more of a for your convenience in the future. What it can do is that instead of changing the, let's say, variables, like you said like variables here, like here, or some float here, and you use this in like many different, let's say, setting, and then whenever you're having new definition, sometimes you have to just redefine this, and it's harder to, let's say, make that accessible for the from the outside, let's say, for the command line. So what it does is that you're basically pulling all these variables to the front, and then you can like, change size and like also like the resolution, name, and all this miscellaneous variables. You can change it in the front of the code. So it's more of an interface tool. Of course, we need TensorFlow because we're going to use TensorFlow a lot. So we're going to shorten it to TF. And I think we already saw this the library yesterday from the TSNE example. And this library is basically you can load and edit some of the image features through the Python. And Matplotlib is a kind of mathematical plotting tool. And PIL is also for the image tool. And this is a mathematical tool for the linear kind of interpolation kind of stuff. I'm not expert on this sort of stuff because this is more of a let's say mathematical tool or science-based tool, but we're just borrowing it to do some simple linear calculation to make our process much faster and easier. And we covered this yesterday too, but then this is let's say a public let's say data that you can download from the guy's research. So this guy developed TSNE as an algorithm, and then he's sharing these feature with everyone who's using the TensorFlow. So whenever you're using the TensorFlow, you can actually download this if you have an internet connection to somewhere. SDP is another mathematical tool. Whenever we have this like a long the library name, we just want to shorten it. And this is called the Keras. Keras is for the deep learning tools. It's mostly used for a lot of machine learning and especially for the image tools. And if you go to the API, they have a lot of stuff that you can use. It's basically a library for the image-based machine learning training, but there are more than just image-based things. It's just one of the libraries that is quite influential over the community.
I have a problem actually.
Yeah.
Like every time I try to import any module, it just says that like it doesn't exist or something like that.
Don't worry about it. Don't worry about it for now. As long as you can write it, it's fine. Okay.
Okay.
Yeah. Because to properly do this, we have to install the TensorFlow on your computer so that the PyCharm knows that all your, let's say, the TensorFlow related library is already in your computer, so that you can call it out. But this installation process is quite complicated, so I wanted to avoid the situation. And I don't know if everyone in the class has the access to the really nice graphics card, at least like 2080 Ti level. So I wasn't sure if that is the right direction. So I chose to do it through the Google Colab, and then we're going to use the Google Colab to actually run the code.
Yeah. I get it.
Mm-hmm. Okay. So just more libraries. You don't have to know what exactly everything is doing. Sometimes you just need to know what to use. And I'm not coming from the coding background as well, so how I learned was just trying to mix and match, and let's see if it works, and learn it by experience. So Python, I really like Python. Let's see. I missed the line. Okay. Yeah, that's correct. For those of you who don't have a lot of experience in coding, in the Python, these dots are used, dots that's used between the words is actually to mark the hierarchy. So all these words, that means that the Python is under TensorFlow, and then Keras is under Python, and then the pre-processing is under Keras, right? And the same for the notation too. So it's a common convention that if you, let's say, have A, and then you want to, let's say, bring out certain features or use a certain function to this, then you will use dot and something. That's a pretty common convention. If you and it's in the Python. In Java, it's a little bit different, but for the Python, that's how it is. Okay. So now we finished the import section, and this is just to bring the configuration of TensorFlow. What we're going to use today is not TensorFlow 2, it's going to be TensorFlow 1.15, because that version is compatible with all this library that we're using. Sometimes a library gets updated later than the TensorFlow. So whenever TensorFlow changes small little things, your library could become not compatible, incompatible. So make sure that you're using the configuration that is correct for your application. Okay. So this is just to call the TensorFlow. You don't really need to know what this does. You just need to put it in. It's same as learning actual language. Sometimes you just need to know what it is. You don't need to worry about grammar and everything. You just need to learn things and then speak. It's kind of similar in the computer language too. And here I'm using this arch parse. This arch parse is a very convenient system where we can call out the multiple variables in the beginning of your code. And how you do that is how do you do the, let's say, add variable. It is by dot add argument. And here we're going to use these two conventions for the size, which is the dash s and then the dash size. When you type in either of these, it will refer to the size, okay? And you have to define the type of a data. There are multiple types of data, integer, float, and all these things, but then you can look into this on online. There are a lot of information available about what types of variables there are and then how they're used. So I'm not going to cover that in the class because we have a long way to go today. And this size is referring to the number of the, let's say it's the size of the grid. So size of the grid means we're going to have this square setting just for the mathematical convenience. What's the, how many grid are you going to have here? It could be 10, it could be 5, it could be 30. So that's what this is doing. Okay, so the parameter is a set. And there is a direction, or more of a directory here. We're going to make the directory as a dir. This is to indicate where your images is to be used as an assembly. And because this is not the specific number, size is like the even, it's a integer is a 1, 2, 3, 4, 5. It's like a number that is a full, not decimal. In this case, because a directory is a like this is directory, and in that case, it is treated as if it's like a text, and then whenever you're using this type of a texting, you're going to call it as a string, and then in the Python, the short for the string is a str, okay? And we're going to indicate what this is doing. Here, this is the source directory for the images. So it is harvesting the images that's going to be used for your TSNE image assemblies to the directory that you assign to the Python code that we write. And there are a few other necessary things that needs to be defined in the TSNE. Now we know that it is one of them is the size, right? Like how many cut are you going to have? But then in terms of image assembly, what other things do you have to consider? Like let's say there is 1, 2, 3, 4, 5 images here. The computer doesn't know how big this image is, yes? So in terms of that, we need to define the resolution of these images. So we're going to define the resolution. And we're going to call this R. We are also going to call it as res. Just for more clear the clarification, sometimes you confuse yourself what is D doing, what is R doing. So for the people who's not so used to these like a shortened version of the conventions, you can also do like full thing resolution here, but I'm not going to do that, but you can do that. So if you're confused, if you think that you're going to get confused, you can literally just like spell it out like this, or you can actually add another string, another, you know, the caller here, which is going to be like this, okay? But for the purposes of this tutorial, I'm not going to use those the full character. And resolution, what is resolution? It's going to be in number. Then what kind of a type of a type of a variables should we use? Anyone? Not sure? We're going to use int, okay? And here, after, or let's say before this and after this and before this, you can actually predefine some of the values. So let's say you can say, as a default, it should be like 512, right? Then let's say you don't define the resolution, then it will pretty much assume that it's going to be 512, the resolution of your image. And this will define the width. Square. Right? And now we're going to give the output a name, okay? So name is the n, or I'll just say name. And name is what? Is name int, float? What is name?
STR.
It's going to be str. Thank you. And we want to give it a default name, because if there is a no name defined, how can the machine, you know, assign a name to an image, right? So I'm just going to say this as test, but for the int, you have to define it as define it within this or not comma word is, I don't know what this is called, but this. And you also have to define the extension of your image file, because if you don't define it, computer doesn't understand. So for this purposes, this version of the TSNE, we're going to define it as a JPG, okay? And then we're going to be kind, and then put the help here. So that, you know, later on, when you get back to it, like a year or 2 years later, you will know what is what, okay? Then what else do we need to add? We need to one thing that could be convenient to add is that we can actually put the out directory. Here we define the in directory, right? The source of the images, but we can also define where your image can be saved. Here we're going to say that as a path. We're going to say that as a path. and as just like the directory, this type is going to be we can set the default as the current folder that you have this the code in. To do that in the Python, you will do dot and the /. If you do this, it will just save your file or the new image into the folder that you have this the Python code in. Okay, so that's kind of a foolproof, right? If you don't define any the output direction, computer doesn't actually save your file. So just to be safe, you're going to have it. But you can change this in any any other location within your Google Drive, or if you're running it on your own computer, you can set this in different things. And how you do that in later on is that you say path and then space, and then let's say let's harvest some directory here like this. We just need to do this. Okay, so that's done, but we still need to build up the help here. Help is the destination. Or eight inch so and here what else could you manipulate in the TSA? What was from yesterday's tutorial? What was the most, let's say, characteristic feature of the TSA? Do you guys remember perplexity? So you can change the perplexity in the in this statement. And because perplexity is a number, we're going to put it as an integer. And you can say some default number. If you don't, anything that I have as a default, if you don't put it in, if you assign 0, like no number or no like a directory, your code will not run. So that's why we're defining the default number or default directory here. So make sure you don't miss these things when you type it in your code for yourself. Okay. And for the default value, I'm just going to put it as a 50, and we're going to put this help as a perplexity amount for okay. And what else? Other than the perplexity, what was another variable that we could control in the testing? It was iteration, right? So we need to do iteration. We need to assign the iteration number as well in the code. Otherwise, machine doesn't know how many times it should run. So I'll just say as iter. This is also a number, so this was integer and default output. I don't know, 5,000. Help and number. Or guessing. Okay, so now we set all the important variables here, and there are some few other things other than the argument versus we can some other things, other useful things. So I'm going to do parse parser dot This just kind of close this out, and we can set out this like out resolution as ours, and then the out name. And this is for your convenience later on to have some sort of unified naming convention instead of find your variable every time when you make a new definition. Okay. So yeah. The square is a square root. This number, we're going to need it later on, because when you measure the, let's say, distance from the here to there, you need these lengths, and the easier way to do is this, right? Complexity equals okay. I hope that I didn't make any typos. Typos are always the enemy. And now we're actually going into the actual coding parts. Okay. So to mark anything, to mark anything, you can do it's like sharp. Sharp is the sort of a thing that you put in as a text here that will not disturb your coding. So above is for import. Yeah, and here you can make a note like this. Above is for import, and above is for yeah. And now we're going into the coding. So as you define here, the arg size here, arg size. This size is we call the out dimension. Out dimension when is 1. This raise function is that let's say that you pop up error message or something. So whenever you want to have some sort of error message pop up, you use raise as the your function. So when this is not correct, what do you think? What do you guys think that this is doing? So for TSNE to work, you have to have multiple grids here. You at least need to have like 2 by 2 or 3 by 3, like something like this, because as a one single thing, there's no correlation between one image to another image, right? So you at least to have 2. So here I'm saying when you set the size as 1, like this size equal 1, this should put the computer in limbo, because it's trying to solve a problem that's never going to be solved. So we're trying to prevent that situation by raising this error message, okay? So we're thinking about like what can go wrong through this process. Like understanding knowing the TSNE, what's the things that we should avoid. And else, if I guess for this one, we don't have to define else because other than this case, everything should be fine, right? But this is another proof book. So if you don't have the directory for your input images, you cannot run the code, right? So you have to check this. So this is the correct, let's say, condition, and if it is not correct, so this now outputs this error message, okay? Right, it's same thing for the out there, because if you don't know where to save it, you know, your computer will not save your image. It will be just floating somewhere in your memory. I'm just being lazy. I'm just going to copy this and change this to okay, this makes sense, right? And now I think that we covered every possible scenario that could, you know, be critical. So this is all full, you know, foolproof. And now we're going to build a model. So whenever you're doing these, like whenever you're making a function, you have to, let's say, define that as a definition. It's a good, I mean, sometimes you don't have to do it for the simple code, but then something that is very complex, it's a good practice to have every function as a separate definition. You know, it's the Python is called the object-oriented coding language, because you can treat every individual variables or the group of an array or group of a definition as an object. Okay, so because of it is the object-oriented the language, computer language, you can do something like this. Like this is an object, and then this is accessory to that object, right? Okay, so now we build model. And don't forget to put this colon here at the end of the definition. And as you remember, as you see here, whenever I use the function, I have this the colon. For the definition of the variables, you don't have to use it, but then for the definitions and functions, you have to use it. Okay. Base model. I mean, we're not going to train our own TSNE. It's already out there, and we're just going to borrow a bunch of the library from everyone on the online. This is just some preset variables that's embedded in the VG16. You just have to call it. Like, let's say you search for the VG16, and then they have all the possible. They would. They have all this like research, and also they should, yeah, here. Yeah, they have all this the functions here that you can use. You can look at their API. API is a kind of, let's say, library section of a library in like a, you know, if this is a library, you have a, like this section is history, like this section is art, and this section is something, and each of them are categorized in a different way, and you have to use a certain language to, you know about these particular, like the subject. It's just like that. So to use your library, you have to know these API, and usually if you go through one by one, it's quite straightforward. You just need to know what to use. Okay, go back here and remember we call this sequential here. We're using this library or more the like add-on. Now we're adding something to this top model. This Platinum is also library that we called here. It's from Tess. And make sure you have the equal number of the closing bracket and then, you know, the starting bracket here. Flatten is just, you know, it makes the image much lighter. And as a return, so whenever you have a definition, everything inside is discrete. So whatever you define inside as a something, as long as you don't return it as a value, it stays inside. So you have to call the value in this return, tab. Otherwise, all the information that's stored in there, unless otherwise defined in somewhere else, it's going to be inside of this definition. That's why we call Python as object-oriented language. So on the return, we're going to get the model. And don't confuse yourself with this. Oh, like what isn't this like base model? Why is he using different, you know, variable here? It's actually the same variable. We're just going to harvest the input part of the base model. So this is the accessory to the base model in a, you know, very casual sense of a definition. So don't get confused. Bracket is the same, and it's returning the model. So the purpose of this whole definition is to get this model, right? Okay. And we're going to write another definition, which is to load the image. To load the image, what should we call? Where is the images? We already defined it. It's in there, right? In there. And we're going to call this call, I guess a thread image is fine. So this is file is a function, and then this path file, path is also function, and lister is also function. So what it is doing is that it is a looping in F as a for loop to search for the how many images are there, and is it the valid file, and if it is a valid file, what's the path? So this is basically loading all the images inside of our image library. So if I go here, there are these images as a kind of sequential thing. There's this images here. Yeah, so it is trying to count how many images there, and then there's the valid file. And then we covered this a little bit yesterday. So to make a, let's say, container, you need to predefine it. So we're going to make this, let's say, loaded images into image collection. What's the difference? So loaded image means that this is image. But what this does is that we're going to bracket it and then put it in a container. Okay, and to do that, we need to use for loop again. Yeah. You can call I or whatever, but I'm just going for the sake of clarity. I'm just going to put the index and the image. There is also this function called the enumerate. It means accounting, like how many things are there, and then we're going to count these images. How many images are there? Based on the index in the image, and after that, because this is a for loop, we're going to have to close this and with the colon, and we're going to define the image because the image is here, right? Image is here. Image. One thing interesting about the Python is that you can actually self-code yourself inside of this, like let's say, relationship. So you can use image as image, and then what it does is that once this image, let me explain a little bit better. So your original image, let's say this is image, is 1, 2, 3, 4. But then inside of, you can actually do this. If you do this, after this loop is done, you're going to be having 1, 2, 3, 4, 5. Does that make sense? So even if it is a same name, you can actually update yourself through this sort of equation.
You can do that in Java, right?
Yeah. So Java, but I'm not sure about actually C++, because there you have to be specific about what you're referring to. But then Java and Python is actually quite similar compared to other language. So yeah, I'm not sure about the C++, but this is a very commonly used in Python. So don't try to overthink it. It's just a name, and the name that even though this information tag and this information tag has a different information inside, it can share one name. Okay, so that's the important part.
Right.
Yeah. Where am I? Okay. And then now because now we define the image, we can make image collection. Image collection, and you remember how I did how I made the image collection? There was a very interesting command called append. It's very often used in the Python. What append does this is that if you get something, like let's say you get a bread, and like you get a croissant and you get a scone, and then you just like put it in the pocket whenever the one loop goes through. So this is basically what this does. But then you can only, let's say in this particular tray, you can only put same kind. Like you can put the croissant and the scone because they're both bread, right? You cannot store various types of information into a append. You can only put, let's say, int or float or something that is like the same kind. That's also one important aspect to use the append in the correct way. And here I'm going to call the load image as a function here. And I'm going to call out the definition that we one, two, three, and so on. Definition that we defined up there. The outres is the image size of individual tiles. So that's the that's kind of defining the target size. And we now have the image collection. So this empty array has been filled from this for loop, from this load image function. You know, this thread image is merely just getting things on the table, and then you sort that things before it. But let's repeat. So thread image is a pour things on the table. Once the things are on the table, you bring a basket, and then that basket is the image collection, and then you put those stuff in the basket, and that's how you make the image collection, basically. Okay, then now we're going to do some mathematical stuff. I'm calling numpy out. Figure out the overall size. It should be bigger than the length of the image collection. Do you guys get why I'm doing this? So if length of the image collection here is the how many images are you going to have as entire data set? So there is a folder here, and then inside of the folder, let's say I have 900 images. Then in terms of the overall image size, what's the maximum can you go with the 900 images? You just need to square root it.
30 by 30?
Yeah, it's 30 by 30. So whenever it exceeds that number, let's say you're trying to draw 31 by 31 with the 900 images. Then what's going to happen with those like rest of a space that you cannot fill up, right? because the 30 by 31 is what? That's 961, right? 961. So what about the 61 images that's going to be empty? Computer doesn't work like that. A human being, maybe you can work this way, but computer doesn't work that way. So it is important to know how many grid that you can have with your current data set. On the folders that I shared as image 128 and then 512. 512 has a 900 images, I think, or maybe a little more. And then the 128 has a 1024. So 120,004, if you square root it, that's 32. So the maximum, the grid size that you can have is 32. If you want bigger grid, you should make more images.
So, quick question. In this case, so MP square always need to be integer, not a float, right?
You mean the out dimension?
Yeah.
Out dimension, we already defined it, right? Out dimension is like, where's the dim size? The size is already integer, yes?
Okay.
And then,
got it.
Yeah,
okay.
we defined it here. Yeah, okay.
Cool.
Yeah. Okay. If that is the case, this is wrong condition, right? This is not a desirable condition per se, because this is bigger than what it can be. So if that is the case, what do? We raise, right? We raise. Because we're kind, we're going to leave this as a message and what I just did here is that on this first bracket, the length of image collection is going to be here. Length of the image collection means that the number of the images that you're going to have in the image collection. And this is the dimension, out dimension that you desire, right? You desire is, let's say, 31 when you can only do 30 by 30, then it will say you can't do that. Yeah. And from this, we will return something. What should we return? What's the most important thing in this function? We work all this way to get this image collection, yes? So we want to return image collection so that we can use this for the later part, right? And next, we're going to activate these images that is going to be used for the TSNE. So these are all the preps to activate these models on TSNE. That whenever you say get, it means that it's trying to activate something. Like, let's say you get like, it's like you're telling your dog to, oh, get that ball. Like that's the same. You know? Get activation. We call this as an activation function, and then the activation is now activation. We're going to make this as an array. Now this is empty for now. It's just like we did here. It's important that you make the empty array first, so that you are not trying to put something in the non-existing tray. What happens when you try to put things in non-tray condition? It just goes everywhere. So don't do that. activation. And we're going to do another for loop because image collection is already in the array. So we want to process this in the for loop. I'm going to repeat the similar process here. We're counting the image collection. By the way, if you guys see any kind of typo, let me know. We have this two plot already defined over here, which is the square root of the out dimension. And then break is a useful function to, let's say, oh, like you should just stop there. You know, like it's a stop button, but it's not completely necessary. But then sometimes this function is useful to save some memory leakage. So on this part, I just put it here because it involves the square root, the calculation. Whenever there is a square root calculation, like computer is really fast on the adding numbers or multiplying number, but square root is a very like computationally heavy actually. So that's why we put the break here, but it's not completely necessary. It just depends.
Sorry for interrupting. So what is the IDX again?
It's a short for index. It's just a variable. It can be I or anything.
Got it.
It's just a variable that you put it. It doesn't matter if you just like say I.
Oh, okay. Got it. Okay.
Yeah. And the same as last time, we're formatting this. We're calling the IDX here. Processing image number what, right? You get here. This is index. So, but then we have to do +1 because a computer starts from 0, not 1, right? So, processing image number 1, image number 2, image number 3. So that's why this is index. Yeah, everything understood?
Yep.
For the purposes of processing image, we want to actually resize the image into this format. Don't ask me why. It's just how it should be in certain cases. For every, like, let's say every algorithm, they might have a different image size requirement. For example, for the SciAgain or StyleGain, it is actually preferred to use anything that is a multiply of a 32 or 16 or 8. So 256 or 512 or 124. You know how our screen resolution is like 1920, and this is because computer likes these numbers, right? So for those kind of applications, you have to use 256, 512 based on how the model is designed. But then in this case, they use a 224 for some reason. So we're going to respect it and use that. To make the blurry images to look a little bit nicer, we're going to use the anti-alias. Anti-alias is very common in the gaming industry. It's a kind of a, let's say, sampling your current images and then make it look nicer. So let's say there is something that looks like a jar, but then in the blurry image it's not sure. But then what you can do with the anti-alias is that you can enhance these edges through some pre-trained data. One of the biggest feature of the 3080 NVIDIA graphics card is that they have a very powerful anti-alias the ability because of the number of the CUDA core they have in the graphics card. So if you have a 30 series, look into it. It's pretty interesting stuff how they do it. This image thing here is referring to this library, PIL library. And among the PIL library, we don't want to import that entire thing. So we just import the portion that is about the image. And then we're calling that function out. And then within that image function, there is multiple things that you can, for example, you can do image to array, which is making array of images automatically using this function. This is another mass expand the dimension. Okay, these some of the things that I don't completely understand, like why I should do it in a certain way, but this is how it should be. But for example, I don't know why they put I have to put the x as 0, but it's just how things are done, I guess. So I'm just following the conventions that everyone's doing for this type of work. So activation is now like doing the same thing as here, image collection append. But then here we're doing this like a squeeze function in NumPy. You can, if you're interested, you can see what it does. But it's related to array manipulation. So, by the way, if you don't know like what each function is doing, you can just, let's say, instead of using just NP, you can say like NumPy squeeze, and you can go search. Then you can find what it is. Just for your future reference. And from here, what do we want? We worked hard to make this activation thing happen, right? So we return activation. Did I say activation? No, correct. So it returns activation, and now we're going to do we're going to generate TSNE based on these images. You see like how like all these functions are kind of making a train. We did this to use this, and we did this to use this. So it's a kind of sequential process. This TSNE with the capitalized letter is imported from the this Skylar manifold. Skylar manifold is the publicly available sort of library about this manifold. It's like very commonly used among the data scientists, but we're just borrowing it to make something interesting. And here, TSNE equals perplexity. Don't confuse yourself here again. So this perplexity is a predefined variable inside of this TSNE function. And then this perplexity is from our perplexity here. So even though it is spelled out exactly the same, this refers to something that is embedded in the TSNE function, and then this perplexity is the what we define. Okay. We define the perplexity, number of the component. We're just going to use 2 for now. Yeah. See this the number of iteration that is belongs to here, and then TSNE iteration we defined it here. Okay, and number of the component is just something that works the best. I just picked something that works the best for our application, and in it is just a preset condition for how they're going to interpolate the variables or the results. Let's say. X to D is our function for, let's say, grid system in a 2D representation. So we are just going to call it X to D, but then it can be just a 2D. Doesn't matter if you keep the same name convention, it should be the same. We're just giving something a name, right? And we're kind of retrofitting, we're fitting our images as an array into the TSNE. And we want to actually subtract something from here. So this is also just like plus plus or this. But this is a known, let's say, the symbol for the subtraction. So if you can also write it in this way. You can write it in this way, but for the shorter writing, shortcuts. Okay. So now we activated the TSNE based on our images, activated images, and then we're going to save this images into let's say, some sort of information array. So we call this save TSNE grid. We need image collection because we want to use like lengths of image collection and stuff like that. We need all this information because in order to save the TSNE, we need to know how many images are in total image, and we need to know how many the grids we're talking about, or how many images, how does the activated images are placed in this grid system. So we need this like a resolution, the dimension of your grid, and the image collection, which is going to be related to this. And this is a process image that's going to be plotted here. Does that make sense? This is like all the variables that you need to make a TSN grid. Grid is NP, and grid is not from anywhere. This is just you know, we're giving it a new name for this information. Stack mesh grid. NOV has all this predefined function that you can use to make something in some sort of like make something, some sort of array into a grid system based on your definition of a mesh grid. So here we're going to use this kind of a definition. What this does right here now is that this is a minimum maximum. So this is 0, this is 1, and then that's one grid. One grid. But how do you define the grid? How big is this gap? That's I mean, it's not about the gap. It's how many are there? The cuts, like line space. So space. How many are there? That's defined by the out dimension. So the number of the grid. So let's say it could be 30, 5, 10, things like this. So that's that line is doing. This is another function, mathematical function that we got in here. Skippy spatial distance. Skippy. Yeah, it has all these like nice the computational functions that is supposed to measure the distance from the one thing to another. If you were interested, you can go into more detail in this webpage as a library. That's so that's another API that we're using. We have this grid. We're going to use grid. D. This one that I'm typing here is just the equation's name or the function's name that I'm going to just call to do the calculation. Like for this is a. So if this is a function, there's a grid, there's an x to d, and there are multiple interchangeable functions that can be that can be used for the CDIST, and then this CQ clean. This is just one of the functions that is pre-embedded in the function. So we're just telling that we want to use this function to process this data. Okay. This numpy float 32 is that it's indicating that it's going to be in the multiplication of a 32. So as I mentioned before, the computer likes this type of number. So float 32 means that the instead of a 0, 1, 2, 3, it's going to have a 0, 32, 64, and then 128. Okay, and that's done. And we now have a, we were assessing everything column by now. And now we want to assess the row. LabJB is also another mathematical tool that I imported here. LabJB is yeah, so it's a linear assignment problem solver. So this is how TSNA is being able to make, let's say, make 3D into 2D. From my understanding, I'm not perfectly sure, but this is essential for the TSNA calculation. And it's for the our application to use the image as a grid system within the let's say this like a logic condition overall the data. So how it does is that make the linear kind of a calculation in some ways. I don't completely understand because I'm not a data scientist, but then as a kind of minimum, let's say, over metaphorical the description, this is what it's doing, I think. But don't quote me on that. Now we're going to update this grid with the calculation that we did with the JB. Out. Multiply by, so this star is a multiply. Why do you think that we're doing this? So our grid is 30 by 30, and then our image size is, let's say, 128. And then here we're saying that we're multiplying these together. To do the, when you do that, you will know how big your entire image is. Yeah. So that's why we do this. And that the pose is actually short for the position. Is used a kind of common convention for the convention for the shortened word for the position. So the position and image in let's say zip. These are the variables that we want to control. From this, we want to define the height and the width. Yeah. Height range is equal to int multiply by. We're doing the subtraction over 1. Based on the dimensions. Assign The reason why we're doing the pose 0, pose 1 is that because we want to make the pose as a two coordinate system. How do you plot your graph? Like let's say this is x, y, and then this is x equals y. Yeah. And the reason why we want to define two variables is that we want to have a position of each image, and the position to indicate the position, we need to know what's x and what's y. And the first thing that comes is 0, right? As I said before, for the computer, 0 is the first thing, and then the first is actually the second thing. So on the first array, if you think about the Excel sheet, there's a column A, column B, and then this is your x number, this is your y number, then you have a multiple coordinates. So you can have like a 0, 1, 2, 2, like 3, 4, right? So this is exactly what it's doing. Okay. Put this out. We want to we're using the same function that we used from each. Where is this? Load image. Here, yeah, activation image to array, which makes them images array using this function. And once that's done, now we have, because our definition hasn't finished yet, so we have we can still use this information and then pause and everything within this function. So we want to make this we are calling this information as a short version. So instead of typing this in every time, we want to use this as IM, which is just standing for the image. And then you can actually put the this .save function at the end. So let's say if you can have some name here, and then when you do .save, you can save your image after plus name. You can also set up the quality of your image. For now, we're going to do 100. So this is for the saving the information. And you notice that there is no actually main function right now. These are just individual functions that's correlating to each other, right? And what main function does in any sort of coding project is that the kind of conductor. So we have to write this like a main definition. I forgot to. Yeah, main definition, and we're going to call model as a build model. We already have this as the function here, build model. Yeah, we're calling this function now in the main folder. And we're going to use each connection as the function that we wrote in the road image. Right. We have this. And the activations same thing here. Okay. So we're going to say it's doing something. What it's doing from this part is that it's generating the 2D representation. So we're going to say it's generating the 2D representation. Here, this 2xd is for this one, so we're calling it here. And from this, we're generating right. Like this was about making the grid, activating the grid. Save TSNE, which is this function. We're calling this just function out. Because it should be executed at the end so that it can output the output image, right? So that's it for the TSNE the coding. Is there any questions so far? Something that's not clear? If there's no question, yeah.
Can you go down to the bottom? I think I just need to finish copying the coding.
Yeah. I'm going to share this code at the end of it, at the end of the class. So don't worry that if yours not working or you have some problem.
And could you repeat, why is it that some of the libraries at the beginning, I mean, for me, they don't work. They are like grayed out, like image, IO, matplot library. Those.
Yeah. So if you have already installed a library, like environment for your, let's say the PyCharm, it should not, gray out. But then, I have all this library in my computer, so that's why it doesn't go gray or dark. But it doesn't matter for our purposes, as I said before. Mm-hmm. We're going to use the Google Colab as our actual platform to run our code. So once you activate the TensorFlow and then import everything, you can import all these assets, all of this assets in the Google Colab. So don't worry. As long as you spelled it correctly, you should be okay.
So are we going to copy all of this code into Google Colab?
We're going to save this as a Python file. We already saved this as a Python file, right? And then what's going to happen is that we put this in the Google Colab, or more like put it in the Google Drive and then call the Python file to run our code in the Google Colab.
Okay, so just one question. I see that, I mean, all of these that we wrote, when you go to file, it says save as, but this is, I mean, should I just overwrite, the existing file? It doesn't have a save, like a save only. It says save as.
So, save all. Don't you have a save all?
Save all.
But like if you can't find it, just save as.
Oh, yeah, save all. Yeah.
Yeah. Okay, and you know where this file is located in your computer, right?
Yeah, I put just users, my name, and it's there. Yeah.
Okay. So is everyone okay with it so far?
Actually, I have a question. So first of all, thanks for go over the entire thing here. But if you don't mind, can we go over again from the beginning? Like, I mean, not one by one, but like just big chunks.
Just
like,
in
so
general.
What, right. What is the purpose and why? What's the reason why we set that kind of like some values over there, and what is the some sequence of that build a model, and what is the purpose, that kind of stuff.
Yeah. Let's do that. Okay. So do you want me to go over from the import section?
No, actually that will be fine because that will be but from the next part.
Okay. Here, so we're on this part. We're making sure that we're using the TensorFlow. Yeah, and then here, as I said before, we're setting up the variables. That's quite crucial, and then most often time used, and then something that we can interchange it every time without actually opening the Python file. So, so here, I don't know if this is big enough to see, but then here I say this is a directory of my file, and this is the size of my file. So you can actually use this command line without actually editing your Python file if you use the parser. Okay, so that's why we're using it. Here, the size is the size of the grid, and then the dir is the directory of the image that you upload. So these small patches, yes, and there is resolution. Resolution is the image resolution of your small patches. To make all this mathematical calculation of how big your image should be and all this kind of stuff. This is crucial. And for name is your output file name. Okay. Output file name, and then the path is actually the outer. If there is an in there, this is the outer. Outer means the output directory. So as I explained here, that's the destination of the directory for the output image. So as a whole, like assembled image, it's going to be saved on the current folder that this Python file is inside. So let's say I have my Python code here in the TSNE Gridmaster. So if I run my code, every time it will output an image inside of this directory if I specify otherwise. If you want to specify the your output directory, you can actually put it here as a, let's say, P or path, like this. But you shouldn't use two, like just use one. I will just use pass for the clarity, and then you can actually copy your directory into this directory, right? The only thing that you need between the directory and the path is just a space here. Okay. Yeah. So So and we have left with the perplexity and the iteration. This you get it, right? Because I did the whole lecture yesterday about how perplexity is affecting the TSNE result, and then the iteration is just the number of iteration that you want to simulate before the final result. So this is all clear, and this here is to actually use some of these variables as a shorten the convention, more of a let's say casual convention. So this @res is a resolution for the input images. Outname, it should be, I think, actually logically it should be in res, but then it doesn't matter really, as long as you know where you're like how you notated your the variables, and the name is just a name, the name of your file at the end, and then the dim is a dimension, which is the size of your file, like size of your grid. And then the to plot here is just another like a variable that's going to be used universally on all the functions. So whenever you define these functions before the definition, any sort of definition, this is a universal the variable. Let me actually write it down on the here. Set for the rest of the code. So instead of saying the rest of the part, I'll say is for set up or define universal variable. Okay, so this is going to be universal variable.
Got it.
And this is all for the foolproof, right? You don't want to have like one by one grid because it doesn't have any correlation between one to another. And then here, this you want to have a directory of incoming images, like where you save the small patches of images. Otherwise, you cannot run the code. So now, like we're telling you, but we're telling the user, oh, like you're doing something wrong. Like it's basically all about that. And then here, now this is a more of a core of the code here. Here we're just building a model. What's the best description? Well, just let's say like a API. And here we're loading image. It's literally a loading image. We named it as a load image, right? But if you have any specific questions about some parts, you should let me know. And this is, we're activating the image. What I mean by activating is get the file ready to be yeah, and here we're generating and here we're saving final result. And, is conductor. Yeah. So does everything make sense?
All right. Thank you. Yeah.
Yeah. Okay. So we're gonna take a 10-minute break from now, and then when we come back, we're going to do some Google Colab and actually get ready to run something. But before you guys go, can you guys actually upload? Actually, you know what? Let's set up a few things first. You guys should go to the Google Colab and then the create new Google Colab file. When you guys did that, let me know.
A new notebook?
Huh?
New notebook?
Yeah, new notebook.
Okay.
For those of you guys if who's following this tutorial right now, would you let me know when you finish this?
Yeah, I have the new notebook here.
How about everyone else? Jechang and Sarita, I know that you guys are following, so good, okay.
Yeah, I just created it. Yeah.
Okay, good, great. So what we're going to do first is to, what we're going to do here is that we're going to connect our Google Drive to the Google Colab. And we're borrowing some code from the Google Colab using Google Colab API, and then we're going to import Drive, and then the next line should be Drive mount /content /drive. This is the location of your drive, and then once you hit this button, play button next to it, it will try to connect. Did I make a mistake here? Google. Yeah, so here it gives you the link, and you click this link, and then you just keep saying yes, and you sign in, and you get this link here, which you can copy by clicking this button, and you can enter this authorization code. Which will let you connect your Google Drive to the Google Colab. So now it says it's mounted. Now we're going to click this plus code button to the save another definition. So here on the pie chart, everything here, whenever you have a new function, you call definition, right? Here, this box is working as a definition. So you know, that's the slight difference. And then we're going to change the directory. The CD is to change the directory, okay? And then Google Colab is very kind, so it's telling you how to use the CD. And then I'm going to say content drive and my and this is like the short for the space, like this backslash, and then the space is short for the spacing in the code. And we're going to make a additional directory inside mkprl. So make directory, that's what it is. And we're going to call this folder name Colab TSNE. Okay. Are you guys here so far?
I guess so.
Okay. And we run this. Okay. Okay. For me, I already made this folder, so it's not going to make the new thing. But then for you guys, it should. So when you're just on the pure like a My Drive folder, there should be a Colab and the TSNE folder created here. Did you guys find that? Let me know once you find it.
For me, I already have a My Drive folder, and in the folder, there's a Colab notebooks folder. And then I created this.
Yeah.
Yeah, that folder. But I don't see any other Colab Colab TSN folders in there.
Can you refresh?
Got it. Okay. Or maybe can I share my screen real quick if you don't mind?
Yeah.
Okay. Okay, so
name CD is not defined. Okay.
And I try to just put this one here, but it didn't work either.
Huh. Let's try some other method. So I'm gonna share my screen again.
Got it.
So here, when you click this folder on the left side, you should see your drive or content.
Yeah.
Like here's the content, and then you should see the drive, and then you should see my drive here.
Okay.
My drive here, yeah. And then you can click this dot button. Yeah, you found it?
Actually, my drive, and yes, I just found the dot button. Yes.
Dot, and then you can do copy path. Copy path. Then you actually just copy and paste. You can paste this here. So it's actually the this one.
Okay.
Yeah.
And then I'll. Okay, so another error message is that name CD is not defined.
Not defined. That's weird. Is there a space between your percentage, the symbol, and
okay, it's this one. All right, here we go. Okay, now
okay,
it just works.
There was a space, right, between your percentage.
Right. Yeah, there was a space. Thank you.
Okay. Now it works. So your folder, the collab folder is here, yes. And then you open it, collab TSNE folder in your drive.
I'll refresh it. Yes, now I can see that.
It's there. Okay. And now you make this. I mean, we can do it in the Google Colab too, but I just wanted to show you that you can, make this directly on the Google Colab without actually making folder here. But then, simply also you can make a Colab TSNE folder in your drive, and it doesn't actually matter as long as you have that folder. So you go in, and then now you make the TSNE grid master folder inside, and inside you see I have this our Python script that we just wrote, and then the images here. I told you guys to download those images right before. Image 128 and then or image 128 or 512. Just pick one folder and then upload that into the this folder under the TSNE grid master with your code.
Okay. Do I have to unzip the files? Or?
Unzip.
Okay.
Yeah.
Also, I need to upload PyCharm files script, right?
The Python script that we wrote.
Oh, okay. Yeah.
So these two,
Got it.
Other than that, this doesn't matter. Yeah. Okay, so just queue the upload, and then from now to until 6:50, we're going to take a break and then come back and then continue on writing the Google Colab notebook. Okay, so that we can actually try to run something today. Sounds good?
We just need to copy the image folder to the Colab TSNE folder, right?
Colab TSNE, you need to make another folder called the TSNE Grid Master, and then under that you're going to upload either these two as a combo or these two as a combo.
Right.
Yeah.
But the Python file is the one that we just did, or are you going to send your?
I will send you mine. Okay, it is up in the chat, so you know you can.
Thank you.
Download. Yeah. Okay, let's come back at the 6:50. Okay, and in the meanwhile, upload those two files.
That's good.
Yeah. See you guys.